Hello friends and welcome back to civilandstructural.com. In the previous part of the subject video, we have seen how to extract the member and forces of a particular member. Here in this video, we are going to see how we can extend that program to suit a more practical approach of our daily routine work. In the previous part, we have learned how to extract member and forces for only one user-defined member. That was enough good to know about the basics of openSTAAD programming. But for the practical use of this code, we are never interested in the member and forces of a single member. What we required is to populate the member and forces for a range or a group of members. On the requests and queries from few of our viewer friends, here I am going to show you how to extract member and forces for n number of members selected in STAAD window itself and for a given user-defined load cases. So let's begin and start thinking innovatively to work smarter and faster. And one more thing, if you like my video at the end, don't forget to subscribe to my channel and don't forget to log on to my website www.civilandstructural.com, where you can download the soft tools which are ready to use in your practical situations. And if you have any queries or doubts, leave your comments in comment box below. Or if you want to write me personally, leave your comments on contact page of my website. So let's start coding. Here I want to populate the member and forces for the load cases mentioned here, and I will be populating the member and forces for starting node of the member and end node of the member. So 6 component at the each end. Here I will populate member and here load cases. Here I have put one formula for how much load cases I want to find out the member and forces. Suppose this is my STAAD file and I want to find out the member and forces for this member, and this member and any number of members. And what I will do, I will just click here and I will get the member and forces for those members at the starting node and end node in this table for given load cases. So how to do it? So as usual, there is a command button here. So we'll start programming. So first step will be to get the selected members from STAAD window. So from where we can get the code, go to help menu, open STAAD help, then open STAAD functions, geometry functions, get selected beams. Simply I will copy this code and paste into my VB window. Here I will remove this one from here. I don't know why they have put it, because it will not work with my programming, so I am deleting that one. So quickly I want to go through this code. This is the definition of our object obj openSTAAD, which is going to help us connect our VB programming with STAAD. Then this cell beam number is going to be used for storing the number of beams selected, and cell beams, this is an array which we are going to use to store the selected beam numbers. Get the application object. From where I can get the application object? Go to the first function. Here I can find the application object. I will paste it here simply. Okay, so with the help of this first command, I am going to get the number of selected beams in STAAD window, and then in second command I am going to get the vector called cell beams which contain the selected beams. Here I have redimensions the array with the cell beam now -1. -1 means number of beams selected -1 means whenever we are going to get an array from openSTAAD command, it will start with 0 index. That's why to arrive at 0 we have to put number of elements -1. So let me check whether this command is working for us or not. I will print the selected beam numbers in our Excel sheet. So for I is equal to 1 to cell beams cells, I will populate the information in my Excel sheet over here, and I will check whether the selected members are being populated correctly or not. So 2 plus 3 plus I and 3 cells 3 plus I 3 is equal to cell beams I minus 1. To start with 0, that's why I have to put I minus 1. Then next I. Let's check. First select the members in STAAD. Okay, select one more. Cell beams no. Cell beams is the array and cell beam numbers is a long. So we have to correct it. Okay, so we are getting correct number of the beams. Let's check 34, 37, 40. 40, 37, 34. It gives you the sequence of selection of the beams. If I select first this and then second this and third this, it will print the member as per the sequence of the selection. So next step is to find out member and forces for these selected beams. We have array of these beams which has been stored in cell beams. So next step will be to populate the member and forces. Output results, get member and forces. See. Okay, there is an error with the coding itself. I will remove these brackets. In last video you might have seen what corrections to be done while copying the commands from openSTAAD. So this command is going to give me the member and forces for this member at the end, that means starting or ending end for the load case, and this is the array of 6 dimensions which being used to store the member and forces fx, fy, fz, mx, my, mz. So I have to define those variables first. So no need to define L member number because already we have an array with cell beams. I have to define end. Okay, control C as long. Let me check once again what type of variable is this. Confirm me. Long variable. Okay. After that, load case. I will choose the same name. C D and this will be array as long. So how many load cases are going to be there? Suppose n number of load cases are there. And from where I can get the information for n? N is equal to cells 1 1. You remember we have put one formula to get the number of load cases here. Okay. So I have to redeem the dimension of this array from 1 to n. So redeem L load case 1 to n. And for I is equal to 1 to n, I have to fill information in this array. So L load case I is equal to cells 2 plus I 1. Next I. Let me check whether I have put correct index for the load case Yeah, this is 2 plus I and first column. That's correct. After that, I have all information with me, so start running this loop for n number of load cases and cell no number of beams. So for I is equal to 1 to number of beams. Number of beams are how much? Here cell B. No, I will copy the same variable to avoid the mistake. Then inner loop will be for number of load cases. For j is equal to 1 to n number of load cases we have. Then I want to put one pointer for here for printing my information in this column, in this table, by varying the number of row of the column. So here I will put one pointer or counter, we can say 1. Initially I have to define p as 0, then cells. Here I am going to populate my number of member names. So 3 plus I 3. So 3 plus p instead of I. P 3 is equal to what? This. Then cells 3 plus p 4, which is equal to load cases. But it has to be j because we are going to use j for load cases in the inner loop. And after that I have to define end is equal to 0 for the first node, first end, that means starting end. So instead of L member now I will put this. L end is correct. Instead of load case I will put this array. And this command will put all 6 components of the member and forces in dforce array. I think I have not defined dforce array, so first define it. Dforce array as, and this is an array of 6 elements, as double. Double. Okay. So to print this information I want to run a loop for this also, and I will take a variable name as k 1 to 6, and where I want to put this information here, that means 3 plus p 4 plus k. Cells 3 plus p and 4 plus k is equal to d force array k minus 1. K minus 1 means to begin with 0 index. Then next k. Simply I will copy this thing for end node. End will be 1. Everything will be same. Instead of 4 I have to put 4 plus 6 is 10. Just let me do some formatting. And then next j, next set obj open STAAD is equal to nothing. Let's check. Okay, so now we have to check. We have populated the information for three beams for the load cases 201 and 202. So let me check our results are correct. Two zero one and 202, and for which member we are populating the information? 34, 37, 40. 34, 37, 40. Go to beam. Here you have seen the unit is Newton, but our default program will give us a result in kilonewton. So nothing to worry about it. Let's check. 34, 265.32 into e raised to something is there. Okay. Then let's check thoroughly. Then Fy is minus 0.843, that is 843, and Fz is 12.378, Mx will be 0, My will be 0.41, Mz is 705.827. That unit is matching here because kilonewton meter. Then for next node you can check 141.427, then 159.237, then Fz is 17.906, Mx is 0, My is 25.55, and then Mz is 282.24. Okay, so we have got the correct result, and this is the requirement of our daily routine work, and this information can be used further to check your moment connections and anything you want to do. And one thing again I want to tell you, important thing, this utility gives you the result regarding the member and forces, and by default, by intuition, what we consider starting end of this beam is this end, but this is not true at every time. That depends on you, and that depends how you model it. If you model this beam from this to this, then starting end will be this. So don't get confused. The whatever we define the end, STAAD gives, or openSTAAD command gives the result for that end. Green means start and blue means end. So keep it in mind that every times it is not that the this end is start end and this end is end. Many people commit mistake while populating this information to check the connections. So this is the video all about, and if you like my video, once again just subscribe to my channel and log on to www.civilandstructural.com to get the more stuff. And thank you for watching this video. Have a nice day.